All right, it is 2 hours UTC, and we're here again. Astronomy Daily Live. Every single day, mostly every day. Once in a while, things come up, and it's like, well, I'm either going to have to hurry or I'm just not going to be around. But most of the time, 2 hours UTC, here we are. So come on in. Come on in, friends. Circle of friends, the ever growing circle of friends. Uh, yeah, so hope everybody's doing well. Got Bobby in the panel again. So hey, hey, hey. Oh, he just walked away for a second. Um, Bobby's there. If any of you ever want to be part of the panel, um, I think there are 10 slots available on Google Hangouts. So just send me an email, cosmiclettuce@gmail.com, and just say, I want to be on the panel, and I'll send you off the link just like I sent one to Bobby moments ago. So what's going on, Bobby?
Nothing much, you?
Everything's good. Everything's good. Just a nice quiet day. I guess it's supposed to. The monsoons are supposed to sort of turn off here, so it's going to get hot, hot, hot. I think Tucson is expected to get into the hundred and teens Fahrenheit on Tuesday or Wednesday. So it's kind of unusual for us to not be having monsoons like every single day. But for some reason, it's decided to turn itself off, and so that means pretty clear skies, which means hot, just really, really, really hot. And the humidity is uh, um, higher than it normally is too. So it's a little on the sticky side, but hey, I'm not complaining in any sense of the word, because I know what others have to endure, and it's I don't think it's anything like this at all. This is very, very mild. So in any case, make sure to get lots of hydrogen and oxygen in you. It's good for you. It's a great coolant. It's a great lube. Um, it uh, makes, well, if you're um, acidic, it makes you more basic, and if you're basic, it makes you a little more acidic. So it's just absolutely amazing, incredible. So cheers. So music from the hearts of space this week was pretty fantastic. Did you hear it, Bobby?
Not yet.
Okay. Yeah, I guess uh, they they have the previous week's show on for free on Sundays. So it's probably still going on now. I don't know. I don't. They're in California, so I I don't know if they shut off the free thing midnight California time, or if it's 0 hours UTC. I'm not exactly sure. But this past week's show was definitely one of the better ones that I've heard in quite a while. Especially the last three songs. The last three are pretty epic, pretty nice. So yeah, I try to record them in the morning, which is probably breaking all the copyright rules and everything else. But okay, tell me to stop, and I will. Or yeah, tell me to stop, and I at least won't talk about it anymore. So, but but record it, and usually by the afternoon, I'll have listened to it already, and that was the case today. I recorded it, and I immediately listened to it. Sometimes I'm just compelled to, and yeah, pretty good, pretty good. I'm gonna get my chat going here. Uncle Bill, how's everything? Hope all is well. Let me get my smartphone running here, the live stream, so I can keep track of things. Oh, I'm gonna mute that thing. So yeah, and those of you who don't know about music from the hearts of space, it's uh, a weekly radio show that plays sort of ambient space, but also like ethnic music and uh, um, sort of hybridized music. You know, they'll mix old sounds and new sounds, and you know, not not necessarily experimental um, in any way, but just nice. You know, generally really cool sound. Um, if you like those kinds of things, it definitely isn't for um, everyone, but I would think that anybody who has an interest in astronomy or space or science would probably sort of, you know, at least their ears, would perk up a little bit when they hear those those kinds of sounds. So yeah, the website is hos.com, and as I said, they have usually a new show every week. Sometimes it's a repeat from previous years, um, but lately they've been doing new shows. So I think this week was a new show, and it was show number 1188. So, and I think they've had a lot of repeats over the weeks. I mean, over the years, but I think they've been, uh, and I mean, it'd probably be easy to find out. But I think show number one was probably 1985, 83, something like that. Oh, you know what? I'm gonna turn me up and turn Bobby down. There we go. There we go. Got to remember to do that. Got to do my job. Yeah, so Hearts of Space, check it out for sure. As I said, what I do is I just record it so I can listen to it at my convenience, and then I can. I like to listen to that kind of music when I'm programming or even even reading papers and or just regular books, because it is supposed to be sort of ambient, right? And at least according to Brian Eno, right, the definition of ambient, he actually, I guess, sort of, I don't know if he coined that phrase, but he defined it. Um, and I'm paraphrasing a little bit here, but um, ambient music is the kind of music that uh, is just pleasant to have in the background without really paying any attention to it, but it's really nice. And then when you listen to it, um, it's actually nice to listen to too. So it's nice if it's in the background, and if it's nice if it's in the foreground. So that is ambient. And Brian Eno, he did quite a bit with ambient, and continues to do quite a bit with
And he's the one that pioneered it, right?
pretty much, pretty much. He, as I said, I think he sort of coined that term. Um, there, you know, um, hindsight is 2020. So there were people who were doing ambient before but he's the one that sort of you know brought it up to the top. Um, but yeah. So definitely, if you haven't heard any of Brian Eno's stuff, um, after after he got out of he was with oh, what was that band? Oh man, I'm not going to remember. I'm going to have to look it up now. Um, he was with a very popular band like in the 60s or 70s. I forget exactly now. Uh, just going to look him up here. Brian Eno. Let's see. Can't remember the group that he was in when he was young. It was in the 1970s, I guess. Roxy Music. Roxy Music. He was in the band called Roxy Music with um, with Brian Ferry. So yeah, he did that first, and he was sort of like a glam rocker, and with all these wild outfits but very good, right? He had a Moog, and I think he had other. I, I don't know if yeah. I mean, there were. I think there were other synthesizers back then, but I think his big thing was the Moog, and he might have had others. Don't remember exactly, but yeah, he sort of started that whole thing after he got out of Roxy Music. Although he was definitely making ambient sounds in Roxy Music as well. So that was really nice to hear some really nice Hearts of Space stuff. Um, as I said, for most of the time it is like that. It's like, wow, this is really good. Once in a while, it's sort of like, eh, you know, not not so good. Um, but for the most part, you know, pretty good shows. To have to do this every week, um, put together a show that's like almost exactly an hour, and have some good sounds. That's probably, well, I don't know how hard it is. There definitely is a saturation of those kinds of sounds out there. So maybe it isn't all that hard to pick out some because there's so many of them. But yeah, not exactly sure how they pick those things out. Um, but very cool anyway. So cheers. And then this afternoon, and I forgot to mention it on yesterday's live stream, but I was over on Rabbit again. It's 0 hours UTC every single Monday. Every single Monday at 0 hours UTC, I go over onto my Rabbit room or channel. I forget what they're called over there, and watch some kind of a movie or video or something like that, and really didn't know what to watch this week, so just pulled out the good old standard and watched a good episode of Carl Sagan's Cosmos. Um, Actually, it was the one that was called "The Lives of the Stars," and you know what? I'm gonna grab my Cosmos book. It's right. It's that dark thing right there. Let me go grab it. Actually, that dark one right there is William Shakespeare. So here's anybody who is getting into astronomy. I highly recommend Carl Sagan's Cosmos, and not only the book, right? Not only the book, but the. Let's see. Do I have it here? I have it here. I've got that out. Got that out. Yeah, I've got that somewhere else. I've got the DVD set, all 13 episodes on DVD, and I've got the soundtrack. Here's disc 2, and there's disc 1. So I can, if I want to, I can be completely saturated in Carl Sagan's Cosmos. Um, Happens relatively often. So what I thought I would do for a little while maybe is just, and I know that this is going to be a little bit hard, but I sort of thought that we could just go through that chapter in Cosmos. The Lives of the Stars is chapter 9. Chapter 9. So there
If
it
you
is.
was off to get the book, the DVDs, and the CDs, how much that would be total?
You know, I'm not exactly sure. I think that my guess is that my guess is that the DVDs are probably, I don't know, you'd have to look somewhere probably between I don't know, $25 and $50. Don't know. Um,
I think the last time I checked, the DVDs were about maybe $70.
were they okay? Okay. Um, the the book I know that you can get used, so you can probably pick it up, for $10. Um, and then the the soundtrack, I don't know, maybe another 20 or so. So probably under $100, something like that. So anyway, here's the chapter heading: The Lives of the Stars. Got a picture of the sun there. Now this book was published, I think, in 1980. If I'm gonna look here, hold on. Yeah, so 1980. So, a little bit of this stuff is a little dated, but the for the most part, it's still, mostly pretty timely. So yeah, the lives of the stars. So he started by uh, saying, and it's actually right in the book here too. Um, I think, does he actually say that here? Yes. So the first line in the show, and actually the last line in the first paragraph of the book, he says, "If you wish to make an apple pie from scratch, you must first invent the universe." And that's so true, right? If you literally want to make it from scratch, then you have to, somehow assemble the protons and the neutrons and the electrons and the atoms and the molecules and everything else, right?
Now, just out of my curiosity, did you watch the 2013 edition of Cosmos?
I I saw it when it came out, and I need, just for continuity's sake, I need to get that set, um, and definitely watch it um, a little bit more. Uh, I'm afraid I'm terribly biased. So what I saw, um, um, Neil deGrasse Tyson do, I wasn't I wasn't overly impressed. Um, but I need to give it a good
I think
chance.
what's good about Neil deGrasse Tyson that he learned from Carl Sagan.
Yeah. The baton was more or less passed, and I think that is very cool. Um, I'm just I'm not I'm not incredibly impressed by Neil deGrasse Tyson for the most part. I think he um, uh, usually when he's out in the public speaking, he his behavior is just uh, a little strange. Um, I saw an interview with him. I'm trying to remember who it was. Trying to remember. I don't know if it was Joe Rogan or if it was somebody else. But that interview, sort of, uh, I noticed, he seemed to be more um, himself, right? He wasn't being goofy. He wasn't trying to be some kind of communicator, um, trying really hard, to impress, and sort of get a message across. He was just talking about things, and that was a good interview. That sort of changed my mind a little bit about him. But yeah, unfortunately, I'm not incredibly impressed by him. Now, I mean, uh, he's doing a fantastic job, and I would never ever, you know, tell him to stop, because I mean, if nothing else, he's having a good time. So it's like, if anybody's having a good time, I'm not going to tell them to stop. There's no way. Um, but whether he should sort of be the representative, for astronomy, that the public sees, and I think, uh, I definitely wouldn't have chosen him. Um, but but yeah, he did do a second series of Cosmos. And apparently, there's a third series coming out. Um, I heard this a little while ago, that they were in some kind of production, to do a Cosmos 3. Don't know what's happening with that, if anything. don't know, don't know. But yeah, I definitely need to give the second cosmos a much better shake, a good look, and haven't had the opportunity to do that yet. So cool. So yeah, he starts by talking about very very small things and very very big things. And as I said, that's one of the things that early on and continues to this day that sort of drives me towards astronomy is the idea that astronomy is one of those things that um, uh, you know you have to have an awareness of the smallest things there are, right? And practically at the same time, right? You have to have an awareness of the largest things there are. Galaxies, clusters of galaxies, and and then you know almost everything in between, which is everything, right? So that's that's definitely what drew me to astronomy, and that is at least one of the things that continues to keep me engaged. See, now I've messed up my terrible camera. There we go. So yeah, he starts talking about the very very small and the very very large. Um, he talks about this number that's called a Google, right? Which is spelled Googol, Google, and that's that I'm pretty sure that is now sort of an accepted mathematical term, right? And it's just one followed by 100 zeros. So that's a Google. That's a big number. That's a big number. And then he talks about this other number that's called a Googleplex. And a Googleplex is a one followed by um, a Google zeros. So that's a lot more zeros. Um, so and that's one of the things in astronomy that you sort of have to get your head around are these numbers, right? Are these very large numbers, these very very small numbers, and a lot of astronomers, especially with the public, right? They try to um, make some kind of impression by presenting all these large numbers and all these small numbers um, that sound extremely impressive and everything else. And I I I try not to do that too much um, because uh, I don't think that is what astronomy is about. Is trying to wrap your head around big things and small things. Um, I think it's about um, um, appreciating those things, um, trying trying to understand them, but you know leaving people with just tons and tons and tons of numbers. Um, I don't know, isn't all that impressive. So I tend to shy away from that. Or take them in stride. So you know when we talk about like an object of the day, right? In some galaxy being, you know,
Now, before you
200.
do an object of the day, here have you ever figured out this is the hardest question ever? What's a gazillion times a gazillion?
Well,
Or
Bonnie,
gazillion plus gazillion?
yeah, you know, um, the exponents just add, so it's no big deal. these numbers are relative anyway. Yeah, you know what's big on one scale is um, small on another scale. So
And
yeah,
besides, it's a gazillion a thing or what?
a gazillion? I don't think so. I don't think so. I think that's a. Uh, uh, I think that just means a heck of a lot. Yeah, I think what there's billion, there's trillion. Um, I think it goes up. It goes up a little ways. Uh, let's see. How can I find that out? I think it goes up to something like 18, 10 to the 18th. I think is. But let's try to find out. Million. I'll just search for million, billion, trillion. I'll bet you that'll names of large numbers. Here, I'm going to share my screen. Large numbers. It's loading. I'll hide that. Okay, so 10 to the 6th is a million. 10 to the 9th is a billion. 10 to the 12th is a trillion. 10 to the 15th is a quadrillion. And then quintillion, sextillion, septillion, octillion, nonillion, decillion, it's 10 to the 33rd, undecillion, duodecillion, tridecillion. Wow, it just goes on and on and on.
Goodness. And no mention of a Google.
Yeah, there's no mention of a Google. What is with that? What is with that? Oh, there it is. There it is. Right there. So, pretty funny. There's even a thing that they're calling a centillion, which is 10 to the 303, which is insane, right? I mean, it's like, come on. So um, there are roughly, you know, um, Avogadro's number is the number of particles in 1 mole of whatever the substance is, and one mole of something is just the atomic weight in grams, right? So HOH, right? Uh, I believe. Um, let's see. There are two H's, so that's two, and then oxygen, I believe, is 16. I think it has 8 protons and 8 neutrons. So the the atomic weight of hydrogen hydroxide is 18. 18. So 18 grams of hydrogen hydroxide would have about 10 to the 24th or 1 septillion molecules in it. So, you know, 18 grams is what, a little more than half an ounce or so. And let's see, I'm going to stop sharing.
Now I wonder, are those like these large numbers? Are they like hard to pronounce and stuff? I know like some of them are easy, but the ones further on down, are they going to be harder to pronounce?
Well, I guess it depends on um, your vocabulary skills. Um, some of them are a little weird, like 10 to the 54th is a septendecillion, and 10 to the 60th is a novemdecillion. So it gets a little weird, but yeah, I don't think too hard to pronounce. But I sort of, I mean, after a little while, right? After a little while, it's like, what's the point of calling, of even talking about these kinds of numbers, right? Because they're so big, right? I mean, we really never encounter anything that big. I mean, you know, really, we'll encounter the largest numbers, that we're going to encounter are
It's kind of a bit sad they don't teach us that in math classes in schools.
all those names.
Yeah,
And as I said, I I don't know if there's any point to that because I mean they're so uh, at least commonly, they're so unused, right? That it's like, yeah, I mean, after a billion or a trillion, you know, those large numbers just really aren't used a lot, right? But I mean, there is definitely more than 18 grams of HOH in this. So there are more than 10 to the 24th molecules just in this little sample right here. Totally amazing because that's a big number, right? That's one followed by 24 zeros. That's a huge number, and it's all in this little cup. Cheers.
yeah.
So we have these big numbers all around us all the time, but they we we're just not aware of it, right? We don't think in those terms most of the time. Now, as a scientist, right, you tend to think about things in those terms, and that that allows you to change your perspective on things, and that's at least one of the things that science is supposed to do, is sort of get you to see things um, in different ways. So yeah, he talks about big numbers, big numbers, and then he starts to talk about you know uh, uh, atoms and the different elements, the 92 naturally occurring elements, um, and then of course there are um, um, elements that can be sort of manufactured. Um, they sometimes don't last all that long. They tend to decay into more stable structures. But yeah, so he starts talking about atoms. Um, then he starts to talk about, it's like, okay, well, where do all these atoms come from, right? It's like, if you follow and accept the story given, what we started with was protons and electrons. So how do we get from protons and electrons, basically hydrogen, right? Um, hydrogen. I think the current thought is that is like 98% hydrogen, 2% helium, something like that. So how do we get from that in a so-called early universe to um, um, what we have now with atoms that have 92 protons in them. How do you do that? And so at least one explanation, one possibility is this idea of nuclear fusion, and that is taking two protons, say, um, and getting them close enough um, to one another that they actually bind to one another. And Carl Sagan, he talks about these hooks, right? So the protons um, are, of course, of like charge, and like charged particles repel each other, right? So under normal circumstances, if two protons get close to one another, they'll actually, repel, right? They'll move away from one another. Same thing goes with electrons. In fact, in fact, uh, now follow me on this, okay? You, if you take your thumb, right? You take your thumb and you push your thumb against like a table or a wall or your chair, right? Now notice what that feels like. Okay, notice what that feels like. Yeah. So push a little hard and um, feel that. What that is the the electrons in your thumb, on the outside of your thumb, right, are being magnetically repelled from the electrons on your table or on your wall. And so when you push, you're actually feeling a magnetic repulsion. So pretty cool, but that's all it is just the electrons are pushing up against one another, and um, you're feeling that. So that is a magnetic thing. It's just like two magnets coming together. It's exactly the same thing. And the cool thing about that is that the particles that are that are actually um, working to create that force that you feel, believe it or not, are photons. They're particles of light going between um, the electrons in my finger and the electrons, for instance, on this desk. Now, we can't see them, right, because they're going right in between those two things. In order for us to see them, that light would actually have to, somehow escape and get into our eyes. It's not going to happen, right? So, but that's exactly what that is. When you push down on something, you're feeling a magnetic force, a repulsive force caused by the fact that the electrons are pushing against one another. So it's very, very cool. But what can happen, right, in the case of protons, is that if they get uh, squeezed hard enough or uh, have enough energy, right, kinetic energy, then they can actually get close enough to what Carl Sagan says are like these hooks, right? Protons have like these hooks, yeah. And if they get close enough to one another, they latch on, right? And that's what is called the a strong nuclear force. Now, whether there is a strong force, I don't know. It seems pretty electrical to me, but what do I know? Um, but these things, at least according to what we think the atom is like, and that is a a nucleus of protons and neutrons, and the neutrons apparently sort of help the protons stick to one another, and then outside of this nucleus, actually quite a distance away, is this cloud of electrons, and it can be between 1 and 92 electrons for naturally occurring ones.
Now, here's something crazy. When a lady touches your face or around your chest area, how do you feel about that?
A what?
Like when you're like if you have a wife or something and like she touched your face around your chest area, around your heart, how do you feel about that?
Well, I mean, I guess it sort of depends on who it is, but I, if it's the uh, most definitely, if that is something that I want to happen, then that's going to be absolutely fantastic for sure. Cheers. But all of that, what you're feeling there, right? Even if you're touching somebody else or something else, that um, sensation, right, um, is actually just a magnetic repulsion. It's an electromagnetic repulsion, and the particles that are actually going in between those two things are photons. So pretty amazing. So yeah, definitely a spark. Definitely a spark. So let's see. So the idea is that stars uh, end up being these factories for making um, elements heavier than hydrogen. So uh, when two hydrogen nuclei um, collide and bond, um, you get a helium nucleus. And once you have a helium nucleus, uh, um, you can build all kinds of other nuclei as well, pretty easily, pretty easily, all through fusion, all through fusion, of course. Let's see, what else do we have here in this chapter? Lives of the Stars. Yeah, you know, he, he goes through uh, sort of how stars evolve, right? And the story there is that there are basically three end um, three possible ends to stars, and it all depends on their mass, how much stuff they actually have um, in them. So a star like our sun, which of course is one solar mass, um, uh, is going to have a pretty long midlife, um, and that's what our sun is in now, is in midlife. Now, 5 billion years from now, it's going to look completely different. Um, at least according to all the models, all the thoughts about this. 5 billion years from now, our sun will be what's called a red giant star. um, probably probably larger than the orbit of the Earth is. So at that phase, the Earth will sort of cease to exist, right? It'll be sort of absorbed um, into this huge star. Eventually, stars like our sun, meaning um, having the approximate mass of our sun, um, will turn into what's called a planetary nebula, and that is the outer shell of the star, sort of the atmosphere, um, gets blown off into space, and the core of the star is left behind. And that core is usually called a white dwarf star. And white dwarf stars are mainly carbon, oxygen, neon, um, and then they have an atmosphere of hydrogen and helium, where actually fusion can still be going on because it's so hot, right? It's still extremely hot. Uh, so yeah, so that's one possible end state. If you have a star that's just slightly more massive than our sun, like 1.5 times the mass of our sun, then that star, at least according to all the models, um, is going to turn into a neutron star. And it's going to have a pretty, potentially a pretty explosive end. Maybe a supernova, maybe, uh, um, you know, some kind of strong explosion, right? Because the nuclear fuel that that was holding the star up against gravity um, uh, um, is used up, and so there's no more outward pressure to hold the star up. It collapses um, and does a little bounce, and I say a little bounce. It explodes, leaves behind a star that is almost all neutrons. So the electrons actually get squeezed into the protons and become neutrons. So you have a neutron star, uh, and then again, this expanding shell of gas and dust around it, caused by the explosion. Now, if you have a star that's maybe 3 or 4 um, times the mass of the sun, um, when it runs out of fuel um, to push out, to hold up against gravity, um, well, there is nothing that can stop that collapse. And apparently, um, this star will collapse and collapse and collapse until it utterly vanishes. It just completely vanishes to absolutely nothing at all, to no size whatsoever. Now, for me, that's sort of a red flag because it's like, okay, you know, zero is a mathematical tool, but I don't know if it's actually physical. I don't. I have a problem believing that there can be um, like a place with nothing, no size. Yeah, I don't know. But anyway, that is the story. Um, and apparently, they call these things black holes because the gravity is so great that even light can't get away from it. So they call it a black hole. They're usually not so black. They're actually pretty energetic objects. Um, and really, as I said, the skeptic in me is like, yeah, black hole might be might be an explanation. I'm thinking maybe something else, and I have no idea what that is. But black holes have always sort of bothered me, um, and I'm I'm looking for some kind of alternative explanation because yeah, I don't know. I don't know. I think we're looking too hard at the math and relying on the math a little bit too much. And when the math says, zero size, it's like, well, yeah, but physically, what is that? What is that? So I think at least one of the ways that they get around that is to define this thing. It's called the event horizon, and um, but even that is sort of a mathematical result. So yeah, you know, we can't we can't confuse ourselves and get caught up in the math and think that the math is the physical explanation. Um, Mathematics is a great tool, um, but you know whether it's effective in this area, don't know. Don't really know. But at least right now, the thinking is that stars can either end up being a white dwarf or a neutron star or a black hole, and all three all three of those events apparently can produce the the all 92 of the naturally occurring um, elements in the abundances that we actually see them. We can sort of run these models of stellar evolution and see it's like you know if you let a star go for 10 billion years and it has a certain mass, it's going to produce a certain amount of stuff, right? And when we look around um, at those kinds of stars and we look and see what kind of stuff they are made of and what kind of stuff they're producing, I think it matches the models pretty well. So, does that mean that what's happening inside of these stars is what the models are telling us? Mm, maybe, maybe. Or are there alternatives? Usually, always, right? I think it was Spock, right? That says there are always alternatives, always. And I think,
Now in Carl Sagan's Cosmos, he said 1,000 years ago we was able to see a great event, like a star exploding. What are the possibilities that that event might happen again?
well, the back back when I was learning all of these things, what I was told was that um, a galaxy will have a supernova about once every 100 years or so, and I think my guess is that number has changed. I think maybe a lot more frequent than that now. Um, but I'm going to go with that. Is that we should, okay, we should see a supernova event in our galaxy like every 100 years. And gotta say, we have not. I think the last supernova in our galaxy was at least several hundred years ago. I don't know where to look that up. Definitely the one in 1054, which is the one you're talking about, Bobby. Um, that one for sure. You know, they've got that date pretty well down, and that is now M1, the Crab Nebula. So that is a supernova remnant. That star exploded um, almost 1,000 years ago, and it was observed. It was observed in the American Southwest. It was observed in Europe. It was observed in China. So it was observed around the world. So this thing actually happened, and it's at least according to the data that they have, which is subject to interpretation, but you know pretty good. They've pinpointed it down to the location of where the Crab Nebula is now.
Now,
So
Andy Calloway, how do we know that the Big Bang was not a black hole explosion?
yeah, I don't think that we do know that, and um, uh, the whole story on how the universe began and how it's evolved. You know, uh, as a scientist, I've got to be skeptical of everything, and that whole story has always bothered me too. Now, I don't have any kind of alternative explanation at all, right? Um, there are just certain things like the Big Bang that just sort of you know bother me. So
Oh, oh I did.
um,
If next time you do your rabbit, show that episode when he shows that cosmic calendar from the time of the Big Bang to about, I think we got like the last 13 seconds of that calendar.
right, yeah, there's a there's sort of a problem with how he talks about that calendar. Um, uh, in that he doesn't talk about the fact that that uh, that calendar is expanding, right? There isn't a next year, right? That calendar is getting larger and larger as time goes by. So, but yeah, thinking in terms of what we think has happened. He actually he introduced the idea of the cosmic calendar uh, back in his book, The Dragons of Eden, um, and he divided the entire um, age of the universe up into 12 chunks, um, and so each each month is about 1 billion years or so, and so yeah, the fact of the matter is that all of human history, recorded um, history uh, on that scale, um, works out to be right. Like the last 10 seconds or so, um, or the latest 10 seconds of the calendar. So yeah, pretty amazing. To think about it in those terms. but you know, I I I don't know. I don't know if we're right about the idea of of um, um, the Big Bang. Um, don't know. Don't know. It's a, I mean, in so many ways, the best story wins. So we probably never. I mean, never say never, but you know, I don't think that we'll ever really know the whole story. I think if we knew the whole story, things just wouldn't be as um, um, interesting and as exciting as they are now. So, I mean, if we know everything, then it's like, well, what else is there? So, cheers. And yeah, Carl Sagan actually said it himself in one of the episodes of Cosmos, and he said, if you want to know what it's like to live inside of a black hole, look around, because in a certain sense, if you agree that our universe is closed, then no light can escape from it, right? Which is the definition of a black hole. So, yeah, lots of ideas. All of them have, their valid points. All of them throw up a bunch of red flags in my head. So uh, I think it's one of those things that yeah, I don't know if what, we'll ever really understand, and I don't know if we want to. Um, Sort of ruins all the fun. Hey, Andy, thanks for the question. Nice to see you in chat. Nice to see you in chat. Trying to see if there's anything else here in the book Cosmos. Can't really see much of anything else. So yeah, I think it's about time to get on out of here. He Where did Carl Sagan actually say this? No, I don't think so. Um, I need to find I need to find a video for you folks and play it. Um, so maybe I will do that at some point soon. It's a great sort of Carl Sagan song that if you haven't heard it yet, I definitely want you to hear it. I will try to play it sometime this week over on Rabbit. It's really, really short. Maybe I can just post the link up so you can watch it at your convenience. But it's pretty awesome. It's pretty awesome. I'll leave it at that at this point. So, all right, I'm going to get out of here for now. So, thanks everybody for coming in again every single day, 2 hours UTC. We're talking astronomy, and it can be, I'm open for any kind of discussion as long as it's astronomical, science. Um, yeah, I'm totally into that. So, all right. Thanks, everybody. I'm going to get out of here for now. Have a great evening, a great day, wherever you are. And I will see you again. More astronomy. There is so much. There's so much that uh, it's really, really hard, to narrow down what to talk about because there's just so much. So, but that makes it very, very cool and extremely interesting. because yeah, the universe is just full of just absolutely amazing things, and finding out a little bit about that is is uh, is very satisfying, right? It's extremely cool. So yeah, I'm going to stick with it for sure. Too much fun, way too much fun. All right, take care, everybody. I will see you on the spin in a little less than 23 hours. All right, take care. Bye.